equations using quadratic techniques. Today we're just going to be solving using rational exponents, okay? So these aren't necessarily going to be polynomials, but these are going to be expressions that we can still write as quadratic techniques, but it's just going to be dealing with fractional exponents or square roots like this, okay? So nothing different from yesterday, just a different look on things. Alright, so here we have x minus the square root of x equals 7. Okay, the first thing, whenever we're solving for x, we want to set it equal to 0. So if we subtract 7 on both sides, we're going to have x minus 6 square roots of x minus 7 equals 0. Okay, now, yesterday, remember the trick that we talked about was that if this exponent was half of that one, okay, is there some sort of relationship between the square root of x and x? Yes, there is, because the square root of x squared equals x. Okay, remember, if you can write things in quadratic technique, this will be your u value, and that is the case here. Because if we look at this, the square root of x squared equals x, that's going to, if we let u be the square root of x, then we're going to have u squared minus 6u minus 7 equals 0. And now we can use our quadratic formula or factoring. I'm going to go ahead and factor. What multiplies together to be negative 7 that adds to negative 6? I'm going to use negative 7 and positive 1, which that's going to give me u minus 7 times u plus 1 equals 0. Okay, so I'm going to set, using my zero product property, I'm going to set u minus 7 equal to 0. And I'm also going to set u plus 1 equal to 0. That gives me u equals 7 and u equals negative 1. Okay, but we're not solving for u, we're solving for x. And u equals the square root of x. So if u equals 47, that means that the square root of x equals 7, and the square root of u equals negative 1. Oops, sorry, square root of x. Okay, so how do I solve for this? How do I undo a square root? I'm going to square both sides. So if I go ahead and square this and square this, I'm going to get x equals 49. That is a solution. This one right here, the square root of x equals negative 1. Can we take the square root of a number and equal a negative number? No. We know that the square root of negative 1 equals I, but here we cannot take the square root of a number to equal negative 1. That's not going to happen. So this part is not going to have a solution. So our only answer here is x equals 49. Okay? Alright. Here we have x to the 1/2 minus x to the 1/4 equals 6. Or minus 6 equals 0, excuse me. What has been our trick to see if we can write this in quadratic form? Is this exponent half of that one? Is 1/4 1/2 of 1/2? I know you don't like fractions, but that is the case. 1/4 is half of a half. Okay, if you're looking at a half of a piece of pie and you cut that in half, you're left with a fourth. Okay, so 1/4 is half of a half. So that means that I'm going to let this guy be my u, because I'm going to be able to see that x to the 1/4 squared does equal, I can multiply those two, 1/2. So I'm going to let u equal x to the 1/4. And that's going to give me u squared minus u minus 6 equals 0. If you want to use quadratic formula, go for it. If you want to use completing the square, go for it. I'm going to use factoring again. So what multiplies together to be negative 6 that adds to negative 1? Negative 3 and 2. So that gives me u minus 3, u plus 2 equals 0. Using my zero product property, I have u minus 3 equals 0 and u plus 2 equals 0, which means u equals 3 and u equals negative 2. We're not solving for u, we are solving for x. So, what was my substitution? U equals x to the 1/4. So if u equals 3, that means x to the 1/4 equals 3, and that means that x to the 1/4 equals negative 2. Okay, how do I undo an x to the 1/4? That's like a fourth root. That means I'm going to take both sides to the 4th power. Okay, which that is going to give me x to the 1/4 to the 4th power is x equals 3 to the 4th is 81. And then here, if I cube both of those, or sorry, take them both to the 4th power, negative 2 times negative 2 is 4, a positive 16. Whenever we're dealing with negative numbers, we always want to make sure that this actually makes sense in the problem. If I were to basically undo what I just did, so here I just fourthed it, if I were to take a fourth root of 16, what would I get? 2, not negative 2. So this one's not going to work. If you were to plug 16 in here, it wouldn't work either. You would have 16 to the 1/2 minus 16 to the 1/4 minus 6. Does that equal 0? 16 to the 1/2, what's the square root of 16? 4. 16 to the 1/4, what's the fourth root of 16? 2 minus 6, does that equal 0? No. That equals negative 4, I think. Yeah, which doesn't equal 0. Okay, so 16 doesn't work. You want to be problem solving as you go through these. So just double check that what you're doing makes sense, like the last problem. So here 81 works, 16 does not. So your only answer is 81. Okay? And last but not least, we have this problem right here. X cubed minus 216 equals 0. This one we do not see a u substitution right away. What we're going to have to do is we're going to have to use a factoring tool all the way back from the beginning of chapter 5, and then use a quadratic technique. Okay, so some of these involve some factoring before moving on with them. So if you have forgotten the difference of 2 cubes formula, I'm going to write it on the board. You might want to have it in your notes in case a big question like this appears on a quiz. So if you have a cubed minus b cubed, that is going to equal a minus b times a squared plus ab plus b squared. So a cubed minus b cubed, a minus b times a squared plus ab plus b squared. Okay? That means that we need to figure out what our a is and what our b is so that we can just drop them into this equation. So we have to figure out, looking at this problem, what are we cubing to get these two items, our x cubed and our negative 216. So here, to cube, what are we cubing to get an x cubed? Well, we are cubing an x. And what are we cubing to get 216? We are cubing a 6. So that means that our a is going to equal x, and our b is going to equal 6. So now we just drop them wherever we see them in this formula. So we're going to have a minus b, which is x minus 6, and then a squared, which will be x squared, plus a times b, which will be 6x, plus 36 equals 0. Using my zero product property, I'm going to set this equal to 0, and this equal to 0, and then solve. So this one, if I add 6 on both sides, I get x equals 6. That is one solution. This one is not factorable, so I'm going to have to use quadratic formula. Or you can complete the square, either way. So I have a equals 1, b equals 6, c equals 36. So equals opposite of b. Up, 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 opposite of b. Plus or minus the square root of b squared minus 4ac. Take it all over 2a. Yeah. So that's going to give me negative 6 plus or minus the square root of 36 minus 4 times 36 is 120 plus 24, 144, is that right? Yes, minus 144 all over 2. 36 minus 144, I'll have negative 6 plus or minus the square root of 108 all over 2, negative 108. Excuse me, don't want to forget that. Okay, so 108 splits up into 9 times 12. 9 is 3 and 3. 12 is 3 and 4. And 4 is 2 and 2. So I'm going to have a group of 3's, a group of 2's, and an I. Okay, so this is going to give me negative 6 plus or minus. I'm pulling out a 3 and I'm pulling out a 2. Multiply those together, I get 6. I have a negative, so I have an I. Square root, my leftovers is this 3. All over 2. I can reduce this, and I can reduce this. So negative 6 divided by 2 is negative 3. Plus or minus 6 divided by 2 is 3. I squared is 3. Okay? So, our solutions. There are 3. We have x equals 6, and x equals negative 3 plus 3i squared to 3, or negative 3 minus 3i squared to 3. And that concludes our 3-part adventure on solving using quadratic techniques. See you guys after spring break.